Hyperconvergence for SMBs. We're really excited to talk with you guys about that this morning. What I want to give just as a quick backdrop of Jacob and I, because I'm going to let Jared here, who's going to be doing a good thrust of the presentation today, give an intro on himself here in just a moment. My name is Logan McCoy. I'm the Vice President of Services here at CCB Technology, been with the company for about 13 years, and I oversee both our professional services team and then as well our managed services team. And I've got with me as well Jacob Tarowski, who is our Director of Enterprise Architecture. And Jacob, if I could have you give a quick intro on yourself as well, that'd be great.
So I've been with CCB for just about 7 years here now, and so I oversee our project side of things, and then what technology we're using. So what servers are we using, what switches, all that kind of stuff. So it keeps me on my toes of kind of staying on top of the new technology that's out there, and then keeping an eye on how we're going to integrate that into what we're doing and how we can implement it.
And Jacob is very well versed, especially in the solution we're going to be talking about today from the Scale side. In fact, Jacob was very early on one of the key drivers in us really looking into this solution and how it could have a great impact on the organizations that we were working with from a technology side. And so for right now, what I'd like to do is turn it over to Jared, who is one of our key contacts over at Scale and is a systems engineer there, very well versed in this solution, obviously. And he's going to be running through for us today, really, what is a hyperconverged solution? How does Scale differentiate itself? Why it's a great solution in a number of different areas, whether you're just an SMB looking to refresh your infrastructure, whether you're looking to move to a hyperconverged solution, and really just what it is overall. So with that, Jared, I'll turn it over to you and take the presentation away.
Yeah, appreciate it. Just a brief introduction. Jared Pexa. I'm the North Central Systems Engineer covering a 5-state territory: Minnesota, Wisconsin, Iowa, Illinois, and Missouri. Been with Scale for a little over 3 years now, but have had some sort of relationship, with Scale for well over 5 years. So I've kind of watched the product grow. I'm really excited to share where we kind of are and why we think we're a really good fit for the SMB market space. And to Logan's point, he did a great job of kind of laying out the agenda here, but I'll make sure that for those of you that are not too familiar with HCI or hyperconverged infrastructure, that we kind of do a level set and then build that eventually into a demo where I'll show you the actual interface and we'll poke around in there. So getting right into it, just a brief introduction on the company as a whole. In case you haven't heard of Scale Computing, we're headquartered out of Indianapolis, Indiana, but we have locations and salespeople across the United States and actually across the globe. From a customer standpoint, we have over 3,000 customers, 10,000 systems deployed, an NPS score of a 91. That's something that we're pretty proud of. I don't know if you've heard of a Net Promoter Score and NPS score, but it's on a scale of a -100 to a +100. We're quite proud to have a 91. Obviously, it's essentially a one-question survey that goes out asking existing customers whether they'd recommend the technology to a potential colleague or somebody else that's exploring the technology. I think you'll see this throughout the demo, but I'll kind of harp on this a lot because really the DNA from a Scale Computing perspective is to have radically simplified management, and to have the enterprise grade features that you expect from your virtualization stack built into the platform, such as high availability and a rockstar support team. And we'll talk about that in a little bit more detail here in the future slides. From a technology partnership perspective, you can see we have a vast array of technology partners. I won't go through all of them. Lenovo is a big one that actually, for a lot of our server-based chassis, is the hardware underneath the hood. But again, to our customers, it's transparent in terms of what's actually the hardware because you're only ever working with Scale Computing, regardless of these technology partners. So what is hyperconvergence? So for those of you that maybe have heard it, but not really explored what is HCI or what is hyperconverged infrastructure, the best way to describe it is kind of thinking about going back in time, essentially, and bringing the storage back internal to the individual hosts, but then taking a software solution to be able to create that storage into a single pool of storage and disperse that across multiple physical nodes is what we call them in the HCI space. So taking that storage back internal to the host and then using a software layer to create that storage to be highly available amongst those hosts and eliminating the need for a SAN. a picture here in the future here, I can kind of depict on what it looked like traditionally versus what it would look like in the future if you were to move forward with Scale. Another key differentiator with Scale is that we're actually bringing this third piece. So a lot of the HCI players in the industry will only converge those first two components. So the servers or the compute and the storage, but then they're still reliant on a third-party hypervisor like VMware or Hyper-V. For us, that's not the case. We're actually bringing the hypervisor into the fold as well. So truly creating a full kind of appliance approach to virtualization. The hypervisor underneath the hood is KVM, but to our customers, it's very transparent, or it's not, you would really never know that it's KVM underneath the hood, because once you actually see the interface, you'll see that, there is no expertise needed. Again, the whole idea from Scale is to have a product that is, an IT generalist can pick up within a couple hours. So this is probably most likely what many of the people on the call are coming from. You'll call this, maybe the traditional infrastructure. The 3-2-1 is what it's often referred to. 3 hosts, a couple switches in a SAN. Some people here at Scale like to call it the inverted pyramid of doom, because everything hinges on that SAN, and if you have an issue with your SAN, that can potentially take down your entire virtual environment. So a couple things with this traditional stack. What we wanted to solve is a few things. One, obviously I hit on it. There is still technically a single point of failure within this stack when you're talking about a single SAN. But probably more importantly is just the complexity. The complexity from the initial implementation, and then really the ongoing management. How do I upgrade this stack? Am I constantly looking at hardware compatibility lists? And it can just get very complex, because you think about it and you start to break it down and you look at the multiple, the number of vendors that are likely involved in a stack like this. I mean, of course, you're likely going to have VMware, ESXi, some host or server vendors. So whether that's Dell or HP or Cisco or whoever that might be, and you're going to have some sort of iSCSI or Fiber Channel network fabric. And then you're going to have your NetApp, EMC, Tegile, whoever that might be, SAN. And then oftentimes there's multiple data protection products layered on top of this as well, maybe a Zerto for replication, Veeam, et cetera. So when you start to break it down, I mean, just to support your virtual infrastructure stack, you're going to have, at a minimum 3 vendors, likely more than that. What that leads to, or can lead to, not always, I mean, don't get me wrong, I've implemented these solutions in the past in another life when I was a solution architect. So I'm not here to bash this, but talk about, where it can create issues. And one of those spots that it can create issues is, potentially having the old finger pointing type scenario where, you have an issue with maybe, I don't know, your SAN, right? You call your SAN vendor. It's like, well, no, that sounds like something happening on the VMware side. And maybe they're pointing a finger back. So what you end up having to do is kind of play quarterback, potentially open support tickets with multiple vendors, and it can be quite challenging, cumbersome, and create some frustration on the end user side, at least for the customers that I've spoken to in the past. So what we set out to do is eliminate that and create, like I said earlier, the single vendor stack for your entire virtualization infrastructure. So again, this is kind of what it would look like from a Scale Computing perspective, a 3-node cluster here where these particular nodes are 4 drive systems that, likely a lot of our clusters, and we'll talk about some of the configuration options, but are hybrid clusters that would have some SSD and spinning disk in that. But, kind of the special sauce, like I said, is to be able to disperse that storage across the multiple nodes in a highly available fashion. And I have some slides here in a couple minutes that will depict how that storage layer actually works and how we're able to achieve that. One of the other big differentiators, again, if you're looking at us for, or if you're looking at the HCI market as a whole, I should say, and maybe you've decided, what, we have a refresh coming up, and I've kind of decided mentally that I want to go with a hyperconverged solution. So Jared, why is Scale different? Well, this is a good slide to depict on really the 2 paths to market from a technology perspective that HCI providers took. There was the left-hand model, which we call the virtual storage appliance or VSA model, that many of our competitors took. And again, not here to bash competitors. That technology is fine. Just here to talk about the differences. Most of our competitors that took that model do not call it a VSA. They may call it a controller VM or OmniStack virtual controller or something along those lines, usually something with the terminology controller VM. Where that can start to create challenges for, kind of our two main market targets is, which are SMB and Edge, is usually the amount of resource overhead you can see in the lower left-hand corner in the red writing required to run that stack is quite substantial. So you're talking about, in a 3-node infrastructure, at a minimum, 96 gigs of RAM and 12 cores consumed by those VSAs running on each one of the nodes. So 32 gigs and 4 cores assigned to each one of those VSAs running on each one of the nodes. You extrapolate that to across 3 nodes, that's where you get to at a minimum 96. So if you think about it, some of you on this call may be thinking, wow, 96 to 300 gigs of RAM, I can run my entire infrastructure within that. And that's what we're seeing very commonly when we're talking to SMB customers, is that they end up, if they do choose to look at one of the competitors in the industry, they end up having to overbuy resources. And that just obviously equates to more cost. So how are we doing it different? On the right-hand side, you can see what we call the integrated hypervisor model. Probably more so, you've heard of that maybe as the in-kernel approach. With our model, there's 2 things that are really differentiated. One is the resource overhead. We're talking about, in that same 3-node architecture, less than 12 gigs of RAM and a fraction of a core consumed, versus the 96 to 312 cores. And then also, if you look at the I/O path, so on the left-hand model, again, coming over to the VSA model, you look at this red line, this is the I/O path that it needs to traverse to do something as trivial as opening a document, changing a period to a comma and hitting save. That's the I/O path to do something like that. You can see it's quite cumbersome because it needs to talk to the VSA on each one of the nodes. For us, it's literally coming from application RAM down to disk, written across the backplane network redundantly to another disk on another node within the 3-node cluster. So again, just to hit on this one more time, that hyper efficiency that we have from an overhead perspective really puts us in a good position for our SMB customers, because we do not need to, oversize them just to get the appropriate resources in there. So diving into the architecture a little bit more, HyperCore is what we call our entire operating system that encompasses all of the components that you're seeing listed on the screen: the network, compute, scribe. Scribe is our storage layer. It stands for Scale Computing Reliable Independent Block Engine. And that's truly what it is. It's a block engine that's doing data placement to particular drives on the lower end. So if you can see here from a storage architecture perspective, again, this is depicting a 3-node cluster here. And we can watch as we kind of build this out what happens. So you have incoming writes onto particular virtual disks that you've created, and you watch the data placement layer is going to make sure that that data is written redundantly and committed to 2 different disks that are, of course, are going to be on 2 different nodes. That's how we're handling the redundancy. What we're doing is we're wide striping and mirroring the data across the individual nodes in the cluster. Wide striping so that we could take advantage of all of the I/O available across all the physical disks, and mirroring, obviously, for redundancy's sake. So you're probably wondering, okay, let me run through some of the common failure events. So most common, if we're talking about a hybrid solution that has spinning disk, I mean, most of the time, if you're going to have a failure, it's going to be a spinning disk. It still has moving components. That's just the most likely failure. So what happens in that scenario? Well, if we look and see we lose that particular disk here, most likely what's going to happen is we're actually going to preemptively fail that drive out if we're noticing error counts increasing. But what happens when we preemptively fail that out is it's going to automatically rewrite the blocks that were on that particular drive redundantly so that they maintain high availability. You can see as blocks 2 and 8 are now rewritten over here on node 1, and the other blocks 2 and 8 are over here on node 3. retaining that redundancy. When we reinsert the hard drive, the kind of the traditional days of like a SAN, right, where you had to make decisions on, different RAID sets that you were going to carve out. And potentially if you didn't have a hot spare sitting around for, maybe a RAID 5 set that you have created and there's no hot spare, well, that could be kind of a nerve-wracking time, right? Because even when that drive does get to you and put back in, the rebuild process, depending on the size of the drives, can be quite extensive, I guess is the best way to put it. For us, again, we're not rebuilding anything. We've already automatically remirrored the particular blocks that were on that. And when we reinsert that particular drive, we're just going to say, our scribe's going to say, okay, I see a new block device, a new drive, and I'm going to kind of prefer that as a right spot over time. And they'll slowly balance it out, but there's no parity recalculations or anything like that happening. So the other thing you're probably wondering about is, well, what happens if an entire node fails? So we'll look at, node 3 fails. What's going to happen is that's going to kick off an HA event, and any virtual machines that were running on that particular node would automatically restart on the remaining nodes in the cluster. So now we talk about backup and DR, and I'm going to kind of breeze through these next couple of slides because I think it's more powerful to actually see it in the UI itself. But what's good to know here is that we do have built-in snapshots and replication into the platform, or built-in data protection that our customers leverage very, very heavily. In comparison to maybe traditional virtualization platforms that you may be running, like VMware, people don't use VMware snapshots all that much. Well, for us, customers utilize our snaps very heavily. And most customers, maybe even if they're not necessarily thinking about it when they're initially talking to us, end up implementing some sort of DR node, DR cluster, or maybe even our DR as a service offering in a partnership that we have with Google. Cloud Unity is what we call it, as you can see here. So there's a lot of options in terms of what you can do. Obviously, with our relationship with CCB, they also have some data protection options as well. If you're not necessarily looking for true spin up on the offsite, maybe just looking for something along the lines of getting the data offsite, CCB does a great job of helping us accomplish that. So if you look at, here's the relationship that we have with Acronis. Again, we leverage CCB via this relationship because CCB has a great relationship with Acronis that can make that a very cost-effective solution. So, and the beautiful thing about Acronis, though, when in relation to Scale, is they have direct hypervisor level tie-in, so that it's that seamless experience that you would expect, where you literally just tell the Acronis management server about your Scale unit, and it's going to automatically pick up any virtual machines that are on Scale, and you can back those up agentlessly. Also, we have the ability to do single node configuration. So very common for potentially sites, robo sites that don't necessarily need high availability. You might put a single node out there and then replicate the data from that single node back to the production cluster or back to a DR cluster, kind of that hub and spoke model. Another common, very, very common use for the single node is to have maybe 3 nodes that are highly available in production, and then a single node sitting in, maybe another facility or another building that you have that's geographically dispersed enough to receive those replicas. And usually that node is sized in a fashion that, it has enough storage to receive replication of all of the virtual machines from the production side, but maybe only enough compute resources to really stand up the mission critical workloads. So just kind of, quick summary here on some of the highlights that we talked about. The hyper efficient IO path, the having no VSA. We don't need a third-party hypervisor, which really helps eliminate complexity and eliminates cost, obviously. Getting to work with CCB and us in terms of the scale care support. The potential integrations that we have with Google Cloud. Again, won't read through all of these, but I think you're getting the point here, that we've really worked to have a product that is really, I guess the best way to put it is it's very resilient for all of the potential unknowns that you have in IT, right? Of, okay, we have the built-in data protection, we have the HA, all the features that you're really looking for in that stack. This is just a good depiction of what the entire kind of line looks like. So one of the things that I really want to highlight when we're talking about from edge to the core, starting on that very left-hand side, and I'll have another slide on this though, is our HE150 series. So the HE150s are actually based off of little, Intel NUC platform. We take 3 Intel NUCs and cluster them, and you're actually able to get a highly available server infrastructure on something as small as 3 Intel NUCs. Well, where does that fit? It fits on, from a enterprise side, and maybe there's some of you that have, multiple edge locations on this call. And that fits very, very well for that particular use case, but it also fits in potential customers that are like, man, like this sounds awesome, but I only have, 2 or 5 or 6 VMs in my entire infrastructure. Well, I have plenty of customers that have utilized what we originally kind of targeted that HE150 for, is the enterprise customers that have thousands of locations, but it also happens to work really well for the SMB customers that say, well, man, I would love to have an HCI solution, but generally speaking, when I've investigated HCI, it's been too expensive, quite frankly. So I've been sticking with like a single node or a single host with VMware on top of it. Well, now this solution with the HE150 makes it realistic for even the S of the SMB to look at HCI. As we move to the right, this just gets a little bit more dense from a storage and compute perspective. Our 3250 DF line is based off of all NVMe SSD for customers that need that true high-end performance. Usually we're putting those in for VDI environments or high performance computing environments. And then the last thing I said here, I wanted to highlight again the HE150 just to look at the different options here. So it can go anywhere from an i3 to an i7 on the processor, up to 64 gigs of RAM and up to 4 terabytes of storage per NUC there. Network's all 1 gig, and you can see the starting app price is $2,000 per NUC. So we can get very, very aggressive in terms of getting down to the right size for the right environment. So with that, I'm going to jump over to a new screen here, and we're going to take a look at the interface. So kind of just doing a top-down approach to what we're looking at here. In reality, by the end of this conversation, you're going to be kind of quote unquote scale certified. It's literally that user intuitive to be able to pick up on some of the day-to-day management of how to set up a resilient scale infrastructure. So starting at the top down, how do you access the scale cluster? Well, you simply point a web browser to any one of the IP addresses of the nodes in the cluster. I happen to be pointed to the first node in the cluster here, but I could point to the second or third. Doesn't matter. We take what we call a distributed management model, where there is no master node in the cluster. Obviously, that would kind of defeat the purpose if there was, because if you lost that node, it would take down the whole cluster. That is not the case for us. We also do not require any third-party management servers to be running anywhere on the cluster. So the equivalent in the VMware world of a vCenter server is not required. All the management capabilities are built right into the nodes themselves. Top center is where you're going to see overall resource utilization. So everything you would expect to see here: CPU, RAM, disk, IO, latency. If you want to dive into your disk utilization a little bit deeper, you can click on the disk dial. This is going to give you a breakdown of what you have free versus VM data usage versus what you're using on your snapshots. Efficiency is going to show you what you're saving with deduplication enabled on the cluster. And then last but not least, provisioned is going to show you, hypothetically, if all of the thin provisioned disk filled up, where you'd net out to on the cluster. But of course, you'd get automatic notifications as you hit certain disk utilization thresholds as well. So, some of them are more informational notices as you hit 60, 70, 80%. But of course, as you get upstream to very high capacity utilization marks, those would become less informational and more warnings like, hey, you gotta do something. Upper right-hand corner where those alerts, warnings, and notices would flow through. Pretty healthy cluster right here. I can tell you what those 6 notices is this is our demo cluster, and we do not have the redundant backplane and LAN ports plugged in. So we're getting some notices here, but nothing, as you can see. The backplane port 1 and LAN port 1 on each one of the nodes is down because they're not plugged in, just because we didn't have enough network ports on our switch. But as you can see, everything's still up and running just fine. Down here, the black, gray, and white boxes are the individual nodes in the cluster. We have a couple different views here. The first view is the RAM view, pretty straightforward. Gray space is the available RAM. The little white boxes are the individual virtual machines running on the particular node. Second view that we have here is the disk view. Again, fairly straightforward. Physical drive disk slot, what's in them, and how much capacity is being utilized. So if you want to find out where a particular machine is living, you know, I mean, this one's pretty easy because we're only got, what, 8 VMs running on this cluster. But if you're talking about maybe you have 50, 60, 70 VMs running and you want to find out where a particular virtual machine is living, you could simply come down to these individual VM tiles. If they're white, that means they're powered on. If they're gray, that means they're powered on, powered off. But if you're trying to find out where a particular VM is living, you could simply click on this move button here. So when I click that, it's going to highlight it. It's currently living on node 2. But if I wanted to live migrate that to, let's say, node 1 or 3, it's as simple as pointing and clicking. So you can see now that that's kicking off that live migration process, moving it over from node 2 over to node 3. Second view that we have here, is the disk view. So one thing to point out here is we do have a multitude of configuration types. So everything from all spinning disk configurations, which is actually what you're seeing here, all the way up to all NVMe, as I previously mentioned. And then probably our most popular configuration actually is our hybrid nodes, which I'm going to jump over here so you can get a look at what that would look like. So if I click on the disk view here, this is a hybrid cluster that has some spinning disk here and some SSD. Now, probably the main reason why I'd say the hybrid clusters are the most popular is because we're able to get a whole bunch of performance out of those without breaking the bank going the all flash route. And it's specifically because we have a technology underneath the hood called HEAT. It stands for Hypercore Enhanced Automated Tiering. And it's doing exactly what it sounds like it would be doing. It's automatically up tiering or down tiering data blocks dependent on how frequently accessed the particular data is. Show you quickly what I mean here is we actually can go down on a per VM basis, even more granular than on a per VM basis, down to a per virtual disk basis and adjust this HEAT priority slider. And when you make adjustments here, what you're really doing is setting the relative priority access to the SSD tier. Now, quite frankly, a lot of customers will just leave everything at the normal setting and let us up tier and down tier data as we see fit. Again, that's based on how frequently data is being accessed. So the net of that is hot data is going to reside on the SSD tier, cool and cold data on the spinning disk tier. However, if you know you have particular workloads, you're migrating over to Scale and you happen to be getting a hybrid cluster and you're like, you know what, I know that I need, you know, my SQL backend for my ERP system, you know, that's very critical. I need that on all SSD. Well, you could simply, when you migrate those over, you could go ahead and allocate and prioritize all the disk for that particular VM up to 11. When you set that to 11, what you're doing is you're actually pinning it to SSD. So we have all these settings from 1 to 10 that are non-absolute settings, meaning we're not pinning it one way or another. We're either just giving it a lot of priority or very minimal priority. But we also have 2 settings that go all the way to off, which would mean you're pinning it to the spinning disk tier, or all the way up to 11, which means you're pinning it to the SSD tier. So just a lot of granularity on how you want to use your most precious tier of storage, which in this case would be the SSD tier in a hybrid environment. So coming down to these blue tiles, now you're probably wondering what these are. Well, these are just what we call groups, logical groupings of VMs that you can use however you see fit. You can see a lot of us, you know, in the SC team have our own little groups of virtual machines here, some of our partnerships. And then you can, you know, if you want to clean this up a little bit, you can, you know, de-expand these or expand these so you can easily find whatever virtual machines you're looking for. Now, of course, we'll have many customers that take the time to go and create some template machines. On this particular cluster, I guess I only have one. If we look at this cluster over here, I think I have quite a bit more. Yeah, so I have like a 2016, a 2019, and a Windows 10 machine here. that I went through and, did all the Windows updates, ran sysprep, ready to be simply cloned off of. So this is the short way of creating a VM. So this is, just going over here, literally picking what you want, which one of my templates I want to clone off of. So let's say we wanted to create a Windows 10 machine for some reason. Go ahead and click clone. We could rename it, redescribe it, regroup it, or tag it. Whatever we need to do. We can even resize drives if we want to, and then go ahead and click clone. And then within a couple seconds, you're going to have a new machine that, whatever particular server roles or whatever applications are going to be installed on that particular machine, you can go ahead and do that very quickly. One other thing to note about our cloning mechanism is that we do what we call fin clones, meaning when I created this clone, even though this is 64 gig disk here, you weren't going to see an uptick of 64 gigs. The way our storage layer works is we already have that data available. We already have those blocks available. So we don't duplicate those blocks. What essentially happens is we use pointers to say, okay, now there's a new virtual machine, this clone machine that's also now referencing those blocks. So we increase the ref counts for those particular blocks. The net of that is you're not, bloating storage, because it's literally consuming at this point basically no storage to create this clone, because it's already exists over here. But of course, as this machine takes on a life of its own, it will start to grow over time, of course, as blocks change and data is added. But that's kind of the short way of creating a VM. I'll show you, I'll come back to this cluster over here and show you the long way of creating a VM, and I'll do air quotes here because you'll see it's quite simple. I think everything that I do within the user interface, is probably done within a few clicks or less here. So we'll give this a name. We're going to call this CCB webinar demo, and then we'll give it a name. So let's say, I don't know, hypothetically, it's a SQL box, and then we're going to give it a tag. Like I said, tags are quite useful. The first tag that you give is going to be where it logically groups it, but then you can give additional tags after that. So let's say I also wanted to tag it as SQL. This still does serve a purpose. I could go ahead and use this filter function over here that's kind of grayed out on the right-hand side of my screen. But that would be able, if I want to filter down by SQL, it would only the machines that have that tag present would be presented in the UI. And then I could do group actions on specifically those virtual machines only. Then you come down here to a very basic choice. So if it's a Windows-based OS, leave it on Windows. If it's any Linux variant or anything, go ahead and select other. Then you come down here to just typical resource allocation. So I don't know, we'll give this guy 4 vCPU, 12 gigs of RAM, maybe an 80 gig system drive, maybe a 300 gig drive for logs, since this is hypothetically a SQL box, and then maybe a terabyte data drive. And we come down here and select what we want to boot from. We'll just boot from server 2012 here and go ahead and click create. Within a couple seconds, we will see that machine created. You're probably wondering, well, where did that list of all of those different ISOs come from? We didn't have to set up an external share or anything along those lines. It's literally coming down to your media tab, drag and drop your ISOs right here, and they'll be available in the drop down for additional VM creation. So if we needed to make any additional changes to this machine, of course we could. If I wanted to make any edits, I simply click on the little edit bar here. But for the purpose of this demo, again, we'll just assume it's ready to be powered up. And I'm going to go ahead and guess that it's going to fire up here on node 2 or .14 here, the middle node in the cluster, because we have technology behind the scenes, state machines that are monitoring thousands of states cluster-wide that really are kind of a lot of the intelligence behind the scenes that help make the cluster self-healing and self-remediating, but it's also monitoring node-by-node resource utilization. So it's going to intelligently place VMs upon initial startup on the node that feels is the best place to start it up on. Biggest driver behind that is going to be, of course, available compute resources. So it's going to intelligently place it here on node 2 because this particular node had quite a bit more resources available than the other nodes. But as I previously showed you, if for whatever reason you don't want it on that particular node, maybe for affinity or anti-affinity purposes, we could simply go ahead and live migrate that to one of the other nodes in the cluster by clicking the live migrate button. Up here, power options, pretty straightforward. This is the default view of giving us an idea of what's going on in the cluster at that point in time. In between those two options is our console view. Pretty straightforward. Just pop open another window here. I would say that our console is quite usable. I use it kind of anytime I'm doing any work in guest. You can see the Windows is starting up here, and I could probably click through that here in a little bit. Coming back down here to devices tab is what we call it. This is going to give us an idea of what we've allocated from a resource perspective, what we're booting from, which is the server 2012, and then our scale guest tools, similar to VMware tools. This includes our in-guest tools and drivers. And then we come down here to the virtual drives that we created. I already showed you the heat tiering. This is where you do it. Now you're not going to see it in this particular cluster because this is all spinning disk. If you need to add a virtual drive, you can do that live on the fly as well without powering down the machine. Simply click on the Add Drive button, type in the capacity that you want to give the new drive, and click Create. Within a couple seconds, we will see that fourth drive created here, that 500 gig drive. Same goes for expanding drives. Simply go ahead, type in whatever capacity you want to expand to, and click Update. Again, this is all being done while the machine is up and running. Makes that management piece fairly straightforward. Last but not least, snapshots. So snapshots and what we have built in from a data protection perspective. So in order to take a manual snapshot, pretty straightforward. Click the camera button, go ahead and give it a name, click enter. A couple seconds later, we'll see that 0 change to a 1 because we have a snapshot to refer to now. Like I mentioned before, our snapshots are quite powerful. Not only are we doing snapshots radically different than what VMware has built in, we're doing what we call an allocate on write style snapshot, which allows for taking, we've tested taking over 5,000 snapshots per VM with no degradation in performance to the actual production VM. With VMware, if anyone's tried to do more than 3, 4, 5 snapshots of a particular VM, you'll know that that can, create issues and potentially crash the machine. On top of that, our snapshots are immutable, are unchangeable. So we have, unfortunately had some customers over the past year that have been hit by things like ransomware or CryptoLocker, and they have been able to go ahead and actually recover utilizing their built-in scale snapshots. And actually some customers had pretty robust backup solutions, not Acronis, but others that I won't name, that actually were infected as well, but the only thing that they were able to recover from was their built-in scale snapshots. Again, I digress, a lot of our customers do utilize the snapshots quite heavily. But of course, they're not paying anyone to click on a camera button every time they need a snapshot. So what are they doing? Well, they're automating that via schedules. So before I click on select a schedule, I'll show you where these are created. You come over here down to schedules, and you can see that we have a few different schedules created here. If we wanted to create one here, we could simply go ahead and call it test. And then you just start adding your reoccurrences and you give them names. So maybe we want a 15-minute reoccurrence. And we come down to minutely. We're going to say we want it every 15 minutes. And maybe we want to keep the every 15-minute ones for 8 hours. And we go ahead and click add. And then we come over here, add a reoccurrence. Okay, we did that. Maybe we want also a 1 hour. And we'll go ahead and over here to hourly. And we want to do it every hour. And we want to keep those maybe for 24 hours. Go ahead and click add. As you can see, you can start, keep adding reoccurrences within these rules. We'll do one more. Maybe we want to do, we'll call this one daily. We want to do it daily. We want to do it every day at midnight, and we want to keep those for 7 days. Go ahead and add that, and so on for however many more rules you wanted to add. I definitely do urge my customers to you don't want to necessarily try to use scale for long-term archival backup strategies. There's better ways to accomplish that. You don't want to utilize your production storage for archival storage anyways. So I utilize this, the built-in data protection we have, more as a business continuity and DR strategy more than anything else. So let's go ahead and say that's a good schedule there. We'll go ahead and save that. Now we're going to go ahead and pick that from the drop-down and click update. Now for the life of this machine, it's going to go ahead and follow that snapshot schedule. So from a data protection perspective, just taking a step back, of course, the active data itself is redundant. That's how we're able to lose one or multiple hard drives or an entire node, or potentially have multiple of those occurrences happening, losing a couple hard drives and an entire node and still not experience data loss on the active data. We have the ability to take manual snapshots here. We have the ability to automate those snapshots. We actually have the ability to even get a little bit more granular on these snapshots as well. So if you go look at any historical snapshot, you can actually expand the historical snapshot and get a view within the virtual disks that were present during that snapshot and be able to clone and mount an individual virtual disk back to the same machine or to any other virtual machine running on your Scale system. So, maybe for some reason, this JP test over here, I wanted to take the 100 gig disk from the snapshot earlier this morning and go ahead and clone and mount it over to our new CCB webinar demo VM. So over here, we're going to have those 4 drives that we've created in our little sandbox VM. So we come over here and say, okay, I want to clone and mount that over here. Go ahead and click clone and mount. Now we're going to see that 100 gig drive or whatever it was be mounted over here. Yeah, there it is. So again, customers, what I see them using that for is maybe doing things like a individual file level restore where they go back to a point in time and then they clone and mount that individual drive to a utility virtual machine or some sort of VM that they have on the system that they can go clone and mount and pull files from. But the last piece of the puzzle is getting the data offsite. And we're getting close to the end here, so stay with me and then we'll get to the questions here. So again, like I said, everything we've talked about so far in terms of the built-in data protection strategy is living locally on the cluster. So unfortunately, if the entire cluster were to go up in smoke, well, we want to get our data somewhere else, right? So that's where the replication piece comes in. So before I click on setup replication, I'll show you where those are created. You come down here to remote clusters, and here you can see that we can add additional remote clusters. I currently have a connection into another 3-node cluster here and also a single node. You do get a live view of what's going on within those particular clusters right there from this single pane of glass view. But if I decided I want to go ahead and replicate this over, I can go ahead and pick that. Let's go ahead and pick Robo. Now that's that single node. I'm going to click replicate. We're going to quickly jump over here and we should see that start to replicate over here fairly quickly. Make sure that got created. It's still getting created, but what'll happen is it's going to follow that schedule that we created right here, because I didn't check. If we go ahead and look at any of these reoccurrences, I didn't check this set different remote retention button. So it's going to just follow the same schedule on terms of what it's keeping locally versus what's being replicated to the secondary site. If you don't want that, you want a different retention policy on what's being replicated to the secondary site, you could simply go ahead and select different remote, set different remote retention, sorry. So if we wanted, okay, hey, we want 7 dailies here, but for whatever reason, maybe on the DR site, I really only want 3 dailies. I could go ahead and click update, and now it's going to follow that particular schedule. If I save that. So a couple other things to note about replication. So of course, the initial replication is going to be a full copy of the VM. After that, it's just going to utilize change block tracking and only send over the changes since the latest successful snapshot. Also, while it's in flight, it's encrypted and compressed while it's in flight, so both bandwidth and efficient and secure. And then in the event that you actually want to fail over, you simply pick the latest and greatest snapshot and go ahead and click clone. And within a couple seconds, you'll have a VM ready to be powered up. So you'll see that these over here are being replicated from my production site over to this DR cluster. And you'll see they look a little bit different, right? Like over here, these machines have the full VM functionality. These are essentially just repositories of snapshots or repositories of recovery points. So you go ahead and pick, most likely it'd be your latest and greatest that you need to recover from, click clone, and then you would have the full VM that's ready to be spun up within a few seconds there. So last but not least, just a couple more things here. So user management. So in the event you want to add additional users, you can set specific parameters, specific abilities that a user would have. Maybe you don't want a particular user to be able to delete VMs or shut down the cluster, but they could do everything else. Updates are handled real slick from a Scale perspective. When you need to initiate one of these, it does not require downtime. So it's all done in a rolling live fashion. So that makes that quite slick. So with that, I think I wanted to make sure we had at least 10 minutes left. So I'm going to stop the demo there and jump back to my slide deck. All right, so Q&A. Bring it back to you, Logan.
Appreciate you going through all of that, giving us a good kind of summation of what it is, how it works, how it functions, how it's different, what the benefits are. That was great. I really appreciate it. And I personally love getting to see the user interface, just getting to see how it functions, what it looks like. I'm such a visual person, and I know that was great. So appreciate you doing all of that. So we do have a number of questions. I think just two I'd like to kind of start us off with here at least and kind of see where they go. And I might actually give this one to Jacob, if you're okay with that, Jared. But the question around this one is, and Jacob, I want to give this one to you because I know we've actually had a couple of use case scenarios. So one of the last ones that Jared was talking about, you've got all these different kind of options we can look at, but for some of those smaller type scenarios, maybe you're talking like the HE100 or those, those 3-node NUC clusters that really can be a small server replacement type of a thing. Where have we seen, or where are we seeing good use case scenarios for that in like actual real world, like what we've done? Can you speak to a few of those examples, Jacob?
Sure. Yeah, we've used them in a couple different places. First and foremost, Jared had mentioned there kind of that distributed enterprise type environment, and so scenarios where you might have a data center or a location where you have your primary server infrastructure, but then you have smaller locations spread around. Those smaller locations are great options to go ahead and put one of these smaller clusters, and it gives you the option to have, or not the option, the availability to have all those features that Jared was showing, that you still get all of your high availability between there. You still have the ability to suffer one of those nodes failing. You have all the same user interface that you're used to there, and then you can take that and replicate it back to your central location. So then that way, if one of those locations goes down, it's super easy for you to bring that workload back up. And so you get the benefits of having server infrastructure at all these different locations without having to spend the same amount of money of putting a full-fledged either cluster location over there, or often cases, they're just putting a standalone server. And while you can do that, you then don't have all those benefits of high availability and everything there. The other side that we've seen these work really well is for that standalone server replacement. So you might be a small business and you have a traditional tower server or something like that, and the resource utilization there isn't very great, but you want to take advantage of things like virtualization in order to get those benefits. These can be a great option to drop in there to replace that standalone single server, and then take advantage of all of the things that Jared was just showing us. So you get the ability to move a machine around, you get your snapshots, you get the ability to clone. So some of that process of, as you're going along, maybe you only have 1 or 2 small servers, but you have a need for something down the road that you're researching right now for maybe another accounting application or something like that. You have those templates that you can do that can expedite your process down the road. Instead of having to spin up a brand new VM, walk through that whole process, you just clone it, and basically in a couple seconds you're up and running. So those have been areas there of kind of distributing that process around, or then sitting in a scenario where you are replacing a single server and you want to take advantage of all the redundancy that's built in there, and the capability of where that type of thing fits really well into a backup scenario. So things with Acronis or other options there that you can use to go ahead and easily back your machines up. You can take advantage of all of that functionality.
Fantastic. Great. Thanks, Jacob. Just kind of looking at the time and knowing where we are, I'll do just one more question for now. So I think that this kind of, came through in a lot of, Jared, your presentation, but then also kind of in what you were demoing there. But I did just have a person ask, so I thought it would be good to kind of come back to it is, so let's say my environment continues to grow over time. And in the past, the kind of standard thought was you just add an additional server. So is it as simple as truly just adding in another node from a resource perspective, and like from a time frame perspective, like how quick is that, how long does that take, all that kind of good stuff, which I know a lot of that you kind of went through, but maybe just a quick recap on that would be great.
Yeah, no, that's a great question, and that's one of the real benefits of Scale. Specifically,
I feel like we do have a competitive advantage even in the HCI space because we have some flexibility. But to first answer that question bluntly, yes, it is as easy as just adding another node. But there's some flexibility on how you want to, or how your company may grow, right? So, you may start with 3 hybrid nodes in a cluster, and we think, okay, hey, we've sized this, working with me on the pre-sale side, trying to take in, all the unknowns of potential growth. But the beautiful thing is we don't have to, kind of the traditional days in the SAN deployments, you would have to kind of project 5 years out from storage growth. And many times what that ended up with is you're just overbuying resources. For us, it's kind of, depending on what your wants and needs are, a lot of customers say, hey, I'm just going to kind of buy what I need now. And then, I know how easy it is to add scale nodes, and to literally add a node is a 15-minute process. You literally tell the new node about your existing cluster. It sucks up the resources. There is no downtime or forklift upgrades or anything like that. But what many of my customers are doing now is they're kind of buying the right resources for what they need for their environment now. Of course, putting in a little bit of buffer if they know that there's some additional workloads coming online, but then, allowing for that step up in that growth to simply add a node when they need the node, which, is kind of a breath of fresh air for customers. And that also leads into potentially being able to do what we call rolling refreshes. So, maybe you start with 3 nodes, and after 3 years, you just start, hey, I'm going to start to add a single node 1 year at a time after 3 years. And so in year 4, year 5, and year 6. And what you've just simply essentially accomplished is now, hey, when those first 3 nodes get pretty long in the tooth, maybe they're 6, 7 years old, I'm going to retire those, but I never have another scenario where I need to come up with a huge CapEx to, replace my entire infrastructure. Now I can actually have some predictability on budgeting and saying I want to add, a little bit bigger, better node each, maybe on an annual basis into my existing scale cluster, and eventually be able to retire those out. That allows for a lot of cost predictability when customers move over to scale. And to my other point, you do have the ability to mix and match those nodes. So maybe you just needed some, heavier on the capacity side of the house. So you want to up the storage capacity on node number 4 or node number 5 that you're adding to the cluster. You can absolutely do that. They don't have to be identical when you're adding them into the cluster. So point is to answer, it's a very long-winded answer, but the answer is yes. It's that easy.
Awesome.
I
Cool.
think that's a really cool thing that you pointed out there, Jared, about not having to necessarily match things identically. That's one thing that we notice in that traditional, cluster model, the iPod, as you were talking about there, inverted pyramid of doom. That aspect of a lot of times when you're doing those nodes, you pick a server and you're buying it now, and it has whatever the current processor family is and things like that. And when you're going to add a 4th node or something larger down the road, you're usually trying to get something in the same processor family in a traditional Hyper-V cluster in order to not have differences between there and cause issues when a machine migrates from an older node to a newer node. And so I think that is a big advantage here of not having to necessarily worry about things being all within the same processor family and having to essentially source older hardware as it's a new node. I need this 3 years later, but I'm trying to kind of sometimes match something that is 3 years old in order to make my cluster happy. Not having to worry about that, I think, is a huge advantage here.
Fantastic. All right. The one thing I did want to mention is if in everything that we've talked about today, especially with Jared and then what Jacob mentioned a little bit ago as well, and you have interest and want to explore this further, if you're at a point of, I really am looking to refresh my infrastructure, whether it's my core or my edge, or I've moved a lot of stuff to the cloud, but I still have a couple of things, a domain server, a file server, maybe a couple small applications that I want to keep on-prem, this is a great solution that we'd love to talk about more how it can fit within what you're looking to do in refreshing your infrastructure. So if that's interest to do it, what you can do is click right on the link that's in the chat and schedule a one-on-one demo there for what works for you to be able to go through and actually do that so we can explore that further with you. And with that, what I do want to say is I want to thank all of the attendees that were on the call today for taking the time to be with us, for going through this webinar. We hope it was beneficial for all of you, that you're going to take away something from it. And especially if this is something you want to dive into further, that again, you click on that link and we'll set up a call with you to discuss this more. So with that, hope all of you have a great day. And I know we're getting to the latter half of the week, so also a great weekend. Thank you.